Good afternoon to all. My name is Asima Kausar. My roll number is 234C1A0208. My topic name is DC characteristics of OP amplitude. Subject name is analog circuits. My topic is DC characteristics of OP amplitude. Introduction to OP amplitude or operational amplifiers are cruel components in analog electronics electrics. They are designed to amplify voltage signals with high precautions and gain. Understanding their DC characteristics is essential for effective current design. Basic configuration. OP amplitude typically have two inputs terminals inverting and non-inverting. The output is the amplified difference between these two inputs. Common configuration include inverting, non-inverting, and differential amplifiers. We can see here comparison of the ideal inverting and non-inverting OP amplitudes. Ideal inverting amplitudes and ideal non-inverting amplitudes. Voltage gain RF by R1. Voltage gain in non-inverting amplifier voltage gain equals to 1 plus R1 by R2. In ideal inverting amplifier, the input is inverting with respect to input. Non-inverting, no phase shift between input and output. Inverting amplifier, the voltage gain can be adjusted as greater than equal to or less than 1. In non-inverting, the voltage gain is always greater than 1. In inverting amplifier, the input impedance is R1. In non-inverting amplifier, the input impedance is larger. Power supply. OP amplitude requires a power supply to function, uh, which can be single or dual. The power supply voltage affects the output swing and overall performance. Typically, the supply voltage ranges from plus or minus 5 voltage to plus or minus 15 voltage for most applications. Input impedance. OP amplifiers exhibit high input impedance often in the megaohms range. High input impedance minimize the loading effect on previous circuit stages. This characteristics is critical for maintaining signals integrity in applications. We can see in this picture microcontrol input modes high impedance. In this picture, they are showing high impedance. Output impedance. The output impedance of OP amplifiers is usually low, often less than 100 ohms. Low output impedance allows the OP amplifier to drive loads efficiently. This characteristics improves the stability and performance of the circuit. We can see in this picture sources amplifier circuit load. Common mode rejection ratio. CMRR measures the um, ability of an OP amplifier to reject common mode signals. A high CMRR indicates better performance in the noisy environments. Typically, CMRR values are expired in disables for clarity. Here CMRR is generally specified in dB. Open loop gain. Open loop gain uh, is the amplification factor when no feedback is applied. OP amplifiers typically have a very high open loop gain, often exceeding thousands times. This characteristics is essentially for achieving desired closed loop gains. In this picture, they are showing negative feedback in OP amplifiers. Closed loop gain. Closed loop gain is determined by the feedback network connected to the OP amplifiers. Feedback can stabilize gain and improve bandwidth in applications. This features allows precise control over the output signal uh, uh, input offset voltage. Input offset voltage is the differential DC voltage required to make the output zero. The parameters affects the accuracy of the OP amplifier in precautions applications. Typically values in the milliwatt, milliwatt range but can vary widely between models. Uh, Slay rate. Slay rate is the maximum rate of the change of the output voltage over time. It limits the frequency response and transient performance of the OP amplitude. Higher slay rates enable the OP amplitude to handle faster signal changes efficiently. Noise characteristics. OP amplitudes generate the terminal and Flexiker noise, which can affect performance. Understanding noise characteristics helps in selecting the right OP amplitude for the task. Proper circuit design can minimize the impact of noise on the output signal. Conclusion: the DC characteristics of OP amplifiers are visual for the effective circuit implementation. Understanding these characteristics aids in optimizing performance for various applications. Careful consideration of parameters ensures renewable and accurate signal processing. Thank you.